In the previous video, we looked at a function where we had a vertical asymptote at a value, and from the left we were going towards negative infinity, from the right we were going towards positive infinity. But it is possible that from both directions we could be going to the same direction of infinity. So let's look at a couple of functions where that happens here. Let's consider the function h of x equal to 3x in the numerator and x plus 2 quantity squared in the denominator. Now, if we look down here, we can already see that at negative 2, we're going to have an issue. And if I use direct substitution at negative 2, 3 times negative 2 gives me negative 6. I have 0 in the denominator, and that automatically triggers that I can say that h of x has a vertical asymptote. Just through that direct substitution trick, h of x has a vertical asymptote at x equals negative 2. But what I want to do now, just like I did in the previous video, is I want to describe the one-sided limits of h of x as x approaches negative 2. And so what I want to do is I want to use the same kind of analyzing whether I have positive or negative values to determine whether it's positive or negative infinity. So if I look at the limit as x approaches negative 2 from below of h of x, well, I know that if I substitute negative 2 in, I get a negative value in the denominator. Excuse me, in the numerator, that would be negative 6. The denominator here, as I approach negative 2 from below, so values like negative 2.01, it actually really doesn't matter which way I am approaching it, because anytime I square, whatever I get here in this value, the square is going to force it to be positive. So if I look at negative 2 from below and substitute it in here, that's going to actually be a negative value in the parentheses, but the squaring turns it positive. And so I'm going to be able to say that I'm headed towards negative infinity from the left side right there. Well, if I look at it as I approach negative 2 from above of h of x, I'm going to get the same idea. Negative 2 in there, that's going to be a negative value in the numerator. The denominator, I'm going to get a small positive value, but still squared is going to still be positive. And so as I approach from that direction, I'm also headed towards negative infinity. So from the left, I'm going to negative infinity. From the right, I'm going to negative infinity. And so I can simply say the limit as x approaches negative 2 of this function is headed towards negative infinity. And again, that's describing a limit that doesn't exist, but it's using the infinity symbols to describe the behavior of that function. Let's take a look at one other function. Let's take a look at what happens when we have p of x equal to 1 over 1 minus cosine of x minus 2. And the question is, what happens at x equal to 2? Well, at x equals to 2, if I substitute it in, the numerator is 1. Down here in the denominator, the cosine of 2 minus 2, the cosine of 0 is 1, so I get 1 minus 1. Direct substitution gives me 1 over 0. So direct substitution tells us there's a vertical asymptote at that value, x equal to 2. But just like I did before, I'm going to go ahead and look at the limit as x approaches 2 from below of p of x, and I want to look at the limit as x approaches 2 from above of p of x and see if we can't describe which direction, positive or negative infinity, we're headed to. Well, as I approach 2 from below, the numerator is always going to be headed towards positive 1, so I know I have a positive value. The denominator here, and this is important where you remember things about the bounded nature of cosine. Remember that cosine is always bound between negative 1 and positive 1. So the cosine of 0 is 1, but I'm always getting to 1 from values just simply below 1. So even from the left here, the cosine of something really close to 0 is getting really close to 1, but it is less than 1. So if I subtract that from 1, I get a positive value here, and so I'm going towards positive infinity for that piece right there. The same is going to be true if I approach 2 from above. I'm going to have 1 in the numerator, so that's positive. The denominator, I'm going to have the same issues. I'm approaching 1 here for cosine, but I never get to a value that's larger than 1 for cosine. So 1 minus something that's really close to 1 but less than 1 is also positive. And so this is also headed to positive infinity. And so I can plainly say that the limit as x approaches 2 of this function is in fact approaching positive infinity.